All right, number 6, the Taylor series for a function f about x equals 1 is given by that formula right there, and it converges to f of x for x minus 1 is less than r, where r is the radius of convergence of the Taylor series. Find the value of r. So we're looking for a radius of convergence here. So we are going to use this power series right here to do that. So we can either use the ratio test or the root test. I would suggest on this one using the ratio test. However, if you went ahead and did the root test, go for it. So ratio test. Remember, this is going to be the limit as n approaches infinity of a sub n plus 1 over a sub n. And so if I do this, I'm going to get the limit as n approaches infinity of 2 to the, and we're ignoring the alternating part because we're just using the absolute value of this, all right? So we're going to get 2 to the n plus 1 times x minus 1 to the n plus 1 over n plus 1, and then it's going to be over the original function, which will be 2 to the n x minus 1 to the n over n. And notice I just rewrote it with the n plus 1 and over the entire denominator just because it will be easier. Now we're going to multiply by the reciprocal, so we'll get 2 to the n plus 1 x minus 1 to the n plus 1 over n plus 1 times the reciprocal, 2 to the n x minus 1 to the n. Okay, and then from here we're going to cancel what we can. 2 to the n plus 1 divided by 2 to the n will just be 2, and x minus 1 to the n plus 1 divided by x minus 1 to the n will just be x minus 1. I still have an n up top, and I still have an n plus 1 down on the bottom. And since I'm letting n approach infinity, at this point if I were to try to plug in infinity, I'm going to get infinity over infinity. So we get to use L'Hopital's rule. And remember, on the real test, actually write out L'Hopital's rule, please. We're going to get the limit as n approaches infinity. If I take the derivative, remember, x right now is a constant, and n is my variable in this problem. When I do that, I'm just going to get 2x minus 1 over 1. So that's all I get. And now, using the ratio test, we know that the absolute value of that needs to be less than 1. And what we're going to do from here, I'm going to, since 2, the absolute value of 2 is just 2, we're just going to pull that 2 out. And now we're going to divide both sides by 2. So we'll get x minus 1 is less than 1/2. And usually we keep going on this, but they just ask me for r, and so I notice right here my problem matches, and so my r is 1/2. And again, you could have rewritten it, we could have kept going on this problem, and you could just take your two endpoints and find the average of those, and you would have gotten 1/2 either way, right? This was worth 3 points. If you set up the ratio, you're going to get 1 point. If you computed the limit of the ratio, so you found all the way to the limit and you ended up getting this is your limit, that would be worth a point. And then if you were correctly able to find that the ratio was the radius was 1/2, you would get a point. Part B, find the first 3 non-zero terms and the general term of the Taylor series for f prime, the derivative of f about x equals 1. All right, we want to find the first 3 terms of f prime. But first of all, we need some terms for f. And I noticed that they gave us the general term for f. So once we get the first 3 terms of f, then we can find the derivative of that. So to get our first 3 terms, we're just going to let n equal 1, and then n equal 2, and then n equal 3. So if I plug 1 in here, I'm going to get negative 1 to the 2 times 2 to the first over 1 times x minus 1 to the 1. And that will give me 2 times the quantity x minus 1. When n equals 2, we're going to get negative 1 to the third times 2 to the second over 2 times x minus 1 to the second. And then that will give me negative 2x minus 1 squared. And then when we let n equal 3, we'll get negative 1 to the fourth times 2 to the third over 3 times x minus 1 to the third. And so that will be positive 8/3 x minus 1 cubed. So what I have just done is found the first 3 terms of f. So f is equal to 2 times the quantity x minus 1 minus 2 times the quantity x minus 1 squared plus 8/3 times the quantity x minus 1 cubed. All right, we want the first 3 terms of f prime, so I simply just can take the derivative of those terms now. So the derivative of 2 times x minus 1 would just be 2, and then minus, if I take the derivative of the next part, this would be 4x minus 1 and then the derivative of the next part, I'm just using the power rule. We're going to get 8 times the quantity x minus 1 squared. So I found the first 3 terms, and then it also said to find the general term for f prime. Well, this is the general term for f, so keeping in mind that n is our variable on this one, we should be okay finding the derivative. Excuse me, x is our variable on this one. So when I'm finding the general term, blah, 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 dot, dot, we are going to, all of this stuff is going to stay the same. So it's still going to be negative 1 to the n plus 1, because that's just a constant that tags along. 2 to the n over n is a constant, it just tags along. And then we're going to bump the power out front, so we're going to make it n times the quantity x minus 1, and then reduce the power by 1. Okay, because again, because we're dealing with f at about x equals 1, we are using x as our variable right now. Okay, and then from here, our n's can cancel, so my general term is going to end up being negative 1 to the n plus 1 times 2 to the n times x minus 1 to the n minus 1. That would be my general term. And they did specify in the directions that we need excuse me, n to be greater than or equal to 1, so we will put that as well. And the points that we would get for this one, this was worth 3 points. 2 points for getting the first 3 terms, so if you got all these, that was worth plus 2, and then if you were able to get the general term, that was worth plus 1. Right, part C, the Taylor series for f prime about x equals 1 found in part B is a geometric series. Find the function f prime to which the series converges for x minus 1 is less than r, and then use this function to determine f. Okay, so we found in part B that f prime was equal to 2 minus 4 quantity x minus 1 plus 8 times x minus 1 squared. So we'll just kind of stick with that. And then it says we want to find the function f prime to which the series converges. So really what this is asking me to do is finding the sum of the series. And so if we're looking for the sum of the series, it's a geometric series. If you remember, the formula for the sum of a geometric series is a over 1 minus the constant ratio. So if I'm looking at this, a is the first term. What is the first term of this series? The first term of that series is 2. And then we need the constant ratio. And if you just look at this, what am I multiplying by every time to get this next term? And I notice that I'm multiplying, if this to get from the first one to the second one, we'd multiply by negative 2 times x minus 1. And then notice if we multiply this second term by negative 2 times x minus 1, we get the third term. So I'm going to say that the ratio is equal to negative 2 times the quantity x minus 1. So to get the sum, we are going to just get 2 over negative 2 times the quantity x minus 1. Oh, excuse me, 1 minus that rate, which turns to plus. So this is going to be 2 over 1 plus 2 times the quantity x minus 1. I am going to go ahead and simplify this. So we got 1 plus 2x minus 1. What did I do wrong here? Oh, this is minus 2 because I have to distribute it, of course. So then when we do that, we're going to get 2 over 2x minus 1. Okay, that equals, it said find the function f prime to which the series converges. So f prime, it's going to converge to 2 over 2x minus 1. Okay, so we got that part. Now it says use this function to determine f. So if I'm at f prime and I want f, we're going to take the integral. So to get the integral, we're going to take the value of 2 over 2x minus 1. Okay, so if we do that, if we take the integral of this, I'm going to do a u substitution. We'll let u equal 2x minus 1. Du will equal 2. Well, very nicely, it's all right there. So this is really just going to be du over u. So the integral of du over u is the natural log of 2x minus 1 plus c, of course. Thank you. And then from here, we just need to figure out our c. And when we do that, we know that f of 1 is equal to 0. So if I plugged 1 in for my x into this original function, we would get an answer of 0. So we know that f of 1 is equal to 0. So I'm going to write 0 equals the natural log of 2x minus 1 plus, well, put 1 in there, sorry about that. This will end up equaling 0 equals ln of 1. null of 0, so we get c equals 0. So f is equal to ln of the absolute value 2x minus 1. So that is my f. And again, where I got this from, I just took, since we're letting x equal 1, just put x equals 1 up in this formula, and that is 0. Okay, so hopefully that made somewhat sense and you're able to get at least a little bit of points out of that. You would get, let's see, what's my scoring? 1 if you correctly found this, that was worth a point. If you took the antiderivative correctly, so if you got something dealing with the ln of 2x minus 1, you get a point. And then if you actually found that that was going to equal, c was going to equal 0, you'd get your third point.